Good morning and welcome to today's lesson. Our lesson today is on the topic sequence and series. In this topic, we are going to look at two subtopics. One is known as sequences, and then the other one is series. A sequence, as you know from the general knowledge, is an arrangement of items in a certain way, in a certain order. So mathematically, when we are talking about sequences, we are going to be looking at a list of numbers which are arranged in order. So for you to get that list, you have to follow a certain rule, a general rule, such that if from the list you want to get item number 10, there is a rule of getting that item. I'll give you two examples of lists of numbers here. Then you tell me whether they qualify to be sequences or not. So we have 0, 3, 6, 9, 12. It's a list. And we have 0, 5, -1, 10, -14. Another list. So if you look at these two sets, you will find that in the first example, you move from 0 to 3, 3 to 6. There seems to be something that is happening. For you to get 3 from 0, it's like you are adding 3. Then you continue adding 3. To go to the next one, you add 3. To go to the next one, you add 3. So you know even to go to the next, you add 3. And the next, you add 3. There's a pattern that is being followed. And there's a rule that's being followed. You are adding 3 as you move to the next. So this first one is a sequence. So is a sequence. What about the second one? 0, 5, -1, 10, -14. Look at it. Is there any rule that is being followed here? Is there any pattern that is being followed? Can you be able to know the next number? I think if you apply all the reasoning and all the rules, you will not get any rule that is being followed here. There is no pattern. They're just numbers which have been written without following any pattern. So the second set here is not a sequence. So not all lists of numbers qualify to be sequences. A sequence must follow some rules. It's a pattern. There's a pattern which is coming out, and you can be able to tell the next rule. Under this topic, we will look at 3 types of sequences. 2 of them are going to be key. One will just to introduce ourselves to the topic. So we are going to look at general sequences for now. The aim of looking at general sequences is to see whether we can be able to come up with a rule. If you're given numbers like you're given these numbers, 0, 3, 6, 9, like that. Now, you know the next one will be 12 because you're going to add 3. And the next one will be 15 because you're going to add 3. For now, we can call this one a general sequence. I have said for now because as we move on, we will be changing its name to another type of a sequence. So when you are given this and you are asked to find the general rule or the rule that can give you the general term. In this topic, the general term is normally given the letter n. So we will be getting the end term. How do you get the end term? If I want to go all the way to an end here, where n is not specified in this case, how do I do that? You're going to look at this, and there is no specific formula for that one. For general sequences, there are no specific formula of getting the rule. So it is a trial and error. For example, here when we have 0, 3, 6, this is the term. So we call this term, it's first term, second term, third term, like that. So n is the number of terms. So if 0 is the first term, then it means here n is 1. And here n is 2. And here n is 3. So n here is referring to the number of term, the nth term. 0 is the first term, so n is 1. 3 is the second term. 6 is the third term. 9 will be the fourth term. Because for the number of terms, you don't skip. It's 1, 2, 3, 4 like that. So you can go up to the 10th term. So if you look at the first term here, it is 0. The second one is 3. So you can do trial and error. So if when n is 1, the answer is 0 here. And when n is 2, the term itself is 3. You can try and look at the rules. If you multiply 3 with the n, and then you subtract 3, let's try that for the first term. So it means for the first term, n is 1. So if you substitute 1 here, you get 3 minus 3, 0. Seems to be working. Try and error. For the second term, n is 2. Put 2 here. 2 times 3, you get 6. 6 minus 3, you get 3. Seems to be working. So for general sequences, you use trial and error to get the nth term. That should not worry you, because in most cases, nobody would ask you to do that. It is mainly a question that does not have a certain way of doing. Sometimes you can be given a general rule and you come up with a sequence. That one is a common one. For example, you can be given a general rule of 2n minus 3. And then you are asked to write the first 5 to 2. 2 times 2, you get 4. 4 minus 3, you get 1. So that will be the second term. The third term, substitute here, n is equals to 3. So 3 times 2, you get 6. 6 minus 3, you get 3. That is the third term. Substitute now n is equals to 4 for the fourth term. You get 8 minus 3, which is 5. Then substitute n is equals to 5 for the fifth term. You get 10 minus 3, which is 7. That is the sequence we are looking for. So it's easier when you are given the general term or the general rule to come up with the terms. But it is also possible for you to be given a sequence and then you come up with the general rule or the general term that is being followed. So we are going to get there for now for this lesson. For general sequences, they don't have a particular way of knowing the general rule. You have to use try and error. So you will do an exercise on that. Try and exercise your skills and see how well you can be able to get the general rule. And also, given the general rule, see how you can be able to come up with the sequence that is being given. So in our next topic, we are going to look at another type of sequence, which is known as arithmetic sequence. So thank you for now and have a nice day. Welcome to this lesson 2 in this topic of sequence and series. In our first lesson, we did an introduction to this topic, and we also looked at general sequences. I hope you did practice on how to get the general rule of general sequences and how to get a sequence given the general rule. So today we are going to go on to a specific type of sequence that is known as arithmetic sequence. This name, from the word arithmetic, gives you some idea of addition. There is something that is being added. So actually, this is the type of a sequence whereby there is a common difference between any two terms. And that common difference is normally referred to as B. or it's given the symbol D. So between the first term, which is normally referred to as A, this is the first term. This is common difference. If you have a sequence, for example, 1, 4, 7, you can see what is going on even without continuing. To move from 1 to 4, what is the gap that is in between? What is the difference here? Between 4 and 1, 4 minus 1, you get 3. What is the difference here? 7 minus 4, you get 3. So there is a common difference. Or, to move to the next, you are adding a constant throughout. So such a term is known as an arithmetic sequence. Or such a sequence, when you form that, it's known as an arithmetic sequence. The first term here is given symbol A. And this constant that is differing between one term and the other is called D. Now, one thing that is very important in this topic is the formulas. And the formula for the general term, the nth term. I told you in the previous lesson that n represents a general term. It could be 10 term, it could be 20. So n would represent any number. So the nth term for this type of a sequence, arithmetic sequence, is given by a formula a plus n minus 1 in brackets d. A is the first term. N is now that term which you want. For example, it could be the 10th term. So if you are asked about the 10th term, then your n will be 10. If you're asked to get the 5th term, then n will be 5. If you're asked to get the 15th term, then n will be 15. Like that. So n is that particular term that you have been asked to get. And then D is a common difference. For example, in this sequence, can we use this formula to find the 6th term? So when you are told the 6th term, this is your n. So n is 6. So the 6th term in this case will be what? Our A is 1, so we substitute here 1, plus n is this one here, 6, minus 1. D is 4 minus 1, which is 3. So you first of all work out what is in the bracket. 6 minus 1, you get 5. 5 times 3, you get 15. 15 plus 1, you get 16. So our 6th term in this sequence will be 16. So it is very important in this case for you to know and remember this formula, because it is the one you're going to apply to get the nth term for an arithmetic sequence. So when you test a sequence and you find that there's a common difference between the terms, automatically it becomes an arithmetic sequence. And this is the formula you're going to use. And you can be given the term itself and you're asked to find n. For example, in the same sequence, 1, 4, 7, all the way to 61. So 61 here is the last term. It's the last term here. If you're asked to find the number of terms, find the number of terms. So the number of terms is n. You still apply the same formula. So we don't know the number of terms, but we know the last term is 61. So 61 is equals to A is 1, plus n, we don't know. 61 is term number what? We don't know. So n minus 1, but we know D is 3. So you can bring this 1 to this other side. So 61, it will be minus. So you'll get 60 is equals to, open these brackets. So you multiply by 3, you get 3n minus 3. Take this 3 to the other side, you will get 63, comes plus, is equals to 3n. Then you divide by 3, divide by 3. So your n becomes what? 63 divided by 3, 21. So the number of terms here from 1 all the way to 61 will be 21 of them. It will be quite tedious for you to write each 1, 2, 3 all the way to term number 21. But it is very easy when you are using the formula. And this formula here is very, very important. So for an arithmetic sequence, the nth term is given by a plus n minus 1 b. I hope that is clear. You can manipulate this formula. Even you can be told to get a. You can also be told to get d. So long as you are given all the others, you can manipulate it, you can work with it and get what is required in a particular question. So we will end our lesson there. Do more practice on how you can use this formula and familiarize yourself with it. And the way to do that is to practice. As you know, practice will make your work perfect. So thank you very much. Have a nice day. Welcome to lesson number 3 in this topic of sequence and series. And our lesson number 3 is on geometric sequence. In our previous lesson, we looked at arithmetic sequence. And we looked at the general formula, or the way you can get the general term, the nth term in an arithmetic sequence. So even here, our main concentration will be on how you can get the general term of a geometric sequence. A geometric sequence, as the word suggests, geometric, is one in which the ratio of the consecutive terms is constant. The ratio of the consecutive terms. So if you have one here like 2, 4, 8, like that, the ratio of the second to the first term, normally start with second to first, 4 over 2. That one will also be equal to 8 over 4, and you can see it is 2. So this one is a geometric sequence because the ratio is constant. You can know the next term will be 8 times 2, which is 16. So if the ratio is constant, then that is known as a geometric sequence. And this ratio is known as common ratio. Remember, for arithmetic sequence, we had something we are calling common difference, symbol D. So this is common ratio, and the symbol here will be R. So the first term, which is 2, in both sequences, whether arithmetic or geometric, is given symbol A. Now, how do we get the next term or the nth term for a geometric sequence? The formula is simple. It is A, that is the first term, multiplied by R, that is the common ratio, and R is raised to power n minus 1. So you subtract 1 from n and you put it as a power of R. What is n? N is that particular term or the number you're looking for. For example, here we can be told to get the 7th term. For this sequence, find the 7th term. So our n here will be 7. So if you are looking for the 7th term here, the 7th term will be 7th term. It's going to be A, which is 2, multiplied by R, which is 2, raised to power n. N is 7, and then you subtract 1 from the power. So this will be 2 raised to power 2 multiplied by 2 raised to power 6. So you can do that one. I think that will give you around a number like 2 raised to power 6 multiplied by 2. That's around 2 raised to power 7. I think it should be 128. You can check. So 128 is our 7th term. It is our 7th term. As we did in the previous lesson on arithmetic sequence, you can also be told to get this n. You can be asked to get it. You can also be asked to get the a. So long as you are given the others, you should be able to work with it, and it is possible to manipulate and get the rest. Another example here, you can be given this other sequence, 1, 3, 9, like that. And you are asked to get the 6th term. The first thing you do is to check whether it is arithmetic or geometric sequence. You can try arithmetic and you find that there's nothing you're going to add for you to get 1, 3 to 9. But if you try geometric, you find that 3 over 1 is the same as 9 over 3, which is 3. And that's our common ratio. So the 6th term, n is 6. So 6th term is equal to a, which is 1, multiplied by r, which is 3, raised to power 6 minus 1. So it is actually 3 raised to power 5. So you can get that from your calculator. Check, I think the answer will be 243. So you can be given that and you can be asked to manipulate that until you are able to move on and get the term that is required. If we change this sequence and start with 9, then 3, then 1. I think it is also a geometric sequence. Because 3 over 9, you normally take the second term divided by the first, then the third divided by the second, like that. The ratio of 2 consecutive terms will be equal to 1 over 3. And that is true, and that is the common ratio. So the common ratio does not have to be a whole number. It can be a fraction. It can be a decimal, so long as it is constant. So in this case, our common ratio is a third. So if you are asked to get the 5th term, for example, if you are asked to get the 5th term, then it will be easy. It will be the same formula. Our a now will be 9. So 5th term, our a will be 9, multiplied by r, which is a third, and that a third is raised to power 5 minus 1. 5 minus 1 will be 4. A third raised to power 4 will be 1 over 81. So it's 9 times 1 over 81. So by 9, 1 by 9, 9. And the answer will be 1 over 9. So that will be the 5th term. So your n, here you have to subtract 1 every time as per the formula, the way it says. But remember, your r does not have to be a whole number. It can be a fraction. And you can manipulate it and get anything that you have been told to get, so long as you remember this formula. Now you have 2 formulas to remember. The one for arithmetic sequence, which is a plus n minus 1 b. That's the way you get the nth term for arithmetic sequence. And now the one for geometric, which is a r raised to power n minus 1. So practice more on that, and you should be good in that area. Thank you very much. Have a nice day. Good morning and welcome to our 4th lesson in this topic on sequence and series. As the topic says, sequence and series. So we are through with sequence. In the last 3 lessons, we have been looking at sequences. And in the next 2, we are going to be looking at series. The other name of series is progression. Series is just addition of the terms in a sequence. If you have these terms in this sequence, 1, 3, 5, 7, that's a sequence. Those are terms. You are putting a comma here for a sequence. But now for a series, we will be adding. So when you get the sum of the terms in a sequence, then that one is known as a progression or a series. So we will be looking at two types of progressions, that is arithmetic progression, which is simply known as AP, and the other one will be geometric progression, which is known as GP or geometric series. So let's start with with arithmetic progression. The good thing and the most important thing you should get here is the formula of getting the sum of any number of terms, n terms of a geometric progression. The formula is only one. The sum, we will symbolize sum with S. Sum of n terms, Sn means sum of n terms, will be given by the formula n over 2 2a plus n minus 1 d. For this lesson, or for this part of the topic, I will not concern myself on how to get this formula. It can be derived. You can look at how it is derived in other areas, but our concern here is not how to derive it, but how to use it. You can learn how to derive it. It's a good way. It's a good mathematical way of deriving this, and you can see how in other areas it is done. But for us, we are not going to concentrate on that. We will concentrate on how to use it. So this is a good formula you should remember on how to get the sum of n terms of an arithmetic progression. For example, and before I go on with the example, you can also use this formula. Sn is equals to n over 2 a plus L, where L is the last term. Last term. That is in case you are given a projection or a series and you have also been given the last term here, you can apply this. So you can choose which one is easy for you to apply. So we will do this example using these two formulas, and then it will be on your side to use or to choose which one you are going to use and which one is easy to remember. So I want us to find the sum of 10 terms, S10, the sum of the first 10 terms in this series. I know it will be easy for you to add with a calculator 1, 2, 3 up to 10, but sometimes you are given more terms like 20. It will be tedious. So these formulas will come in handy. Let's start by using the first one, option 1 or method 1. Sn, so we are looking for S10. So it is equal to 10 over 2, which is n over 2. So our n is 10 because we are looking for the sum of 10 terms. N over 2, 2a, that is 2 multiplied by 1 because our a is 1, plus n minus 1, our n is 10, d is what? 3 minus 1, which is 2. There we go. So we simplify here, I get 5. Here I get 2 plus, open this bracket. You can first of all subtract. To 10 minus 1, you get 9. 9 times 2, you get 18. So 18 plus 2, you get 20. 20 times 5, you get 100. So the sum of the first 10 terms in this progression is 100. Method 2. Method 2 would require you first of all get the last term. The last term is the 10th term because you want the term number 10. So you will have to go back now and use the other formula, the one I taught you in lesson 2, of a plus n minus 1d, of getting the nth term. You remember that one? Such that you get term number 10. What will it be? Term number 10. Where n now will be 10. So it will be 1 plus 10. You put 10 minus 1 here, you get 9. 9 multiplied by d, which is 2. So this is 18 plus 1, which is 19. So your last term, which is the 10th term, is 19. You can even write it here, 19. So you're going to use now this other formula here. So we get S10 using the same. It's easy. So N is 10. So 10 over 2. A is the first term, which is 1. Plus our last term, which is the 10th term now, is 19, as we have gotten here. 19. So you do that, you will get 5. Multiplied by what? This is 19 plus 1, 20. The same thing, you get 100. So the formulas will lead to the same answer, but you can choose which one. Sometimes you are only given in a progression the first, second, and maybe the last. So you will have to use this formula, whichever the case. So it is good to learn both. It is good to know how to use both formulas. Practice on that, and you can also be told to get anything from the formula. You can be given the sum, you get n. You can be given the sum and n, you get a. You can be given everything else, you get d. So you should learn how to use both formulas, and by so doing, you can get anything that has been asked. And the best way to put a formula into your head is not to cram. It is to practice using that formula, and every time you are using it, write it down so that by practicing, you get to use it and it sticks into your head. It is easy to know it. So that is how you work out arithmetic progression. Thank you very much. Practice more and you'll become perfect. Have a nice day. Welcome to our fifth and final lesson in this topic of sequence and series. We have looked at the whole part of sequence, and in the previous lesson, we looked at arithmetic series or progression. So today, we are going to look at geometric series or geometric progression, which is symbolized as GP, geometric progression. Just as in the previous case of arithmetic progression, the most important thing here is knowing the general formula. I may not take you through how to derive the general formula, but we are going to look at the general formula, the finished product, and how to apply it in our case. So for geometric progression, unlike arithmetic progression, we have two formulas, but they are very closely related. It depends on the common ratio, because you remember in a geometric progression, we have common ratio and not common difference. So the sum of n terms is given by a r raised to power n, then you subtract 1, then r minus 1. Remember, this minus 1 is not in the power. So r is just power n. There is no, minus 1 is not in the power. When you do r minus 1, the answer you get from the calculator, then you subtract 1. This formula is used when r is greater than 1. Remember, we had said r does not have to be a whole number. It can be a fraction. Sometimes a fraction which is less than 1. So when r is greater than 1, then this is the formula to use. When r is less than 1, you just change the formula a bit. It's the same, but you just interchange. Why do we interchange? So that we don't get a negative. Just making sure we have a positive that we are working with. That does not mean that the sum cannot be a negative. It can be a negative, depending on the terms that are there. So still a is outside the bracket, but now instead of starting with r raised to power n, we start with 1. So we just interchange. We start with 1. And then also in the denominator, instead of starting with r, we start with 1. So 1 minus r. This one is where r is less than 1. Just to make sure that we have something that is workable, and the values here, especially the denominator, is not a negative. So with this, you can be able to work out NA. So the most important thing is to be able to look at a question and know if r is 1 or is greater than 1 or less than 1, then you know which formula to apply. Let's look at two examples to give us both scenarios. Let's look at this. Assuming that is a progression, you can look at it. It is actually geometric. What is R? R is second term over the first term, or third divided by second. So it is going to be 3. So 3 divided by 1. So you can see that in our case here, R is more than 1. And the question is, find the sum of the first 10 terms. 10, now in that case, is your n. So the formula is the first one here. So we apply it. So S10 is equals to, in this case, A, which is 1, multiplied by R, which is 3, raised to power 10, then we subtract 1, divide by R, which is 3 minus 1. The best thing here is to work out with a calculator and start by working out what is in the brackets. So take your calculator, key in 3 raised to power 10, then put equals. Before you press the AC button, then subtract 1. Put equals again. If this number was not 1, you would have multiplied with the number. If it was 3, for example, you'd have multiplied by 3. But now it's 1. It does not make any difference. Then the answer you get here, you divide by 2, because 3 minus 1 is 2. When you do that, you will get a number which is 29,524. So that is the sum of the first 10 terms. You can see it's a big one because it's geometric. The number continues increasing by a factor of 3 as you move on. As we had used in the previous example, let's interchange this. So if the progression is this way, R here is now different. It is not 3. It's going to be 3 divided by 9, which is a third. So R is a third. So if R is a third, we are going to use the second formula, not the first one, because the second one is where R is less than 1. So let's get also the sum of the first 8 terms in this one. Find sum of the first 8 terms. That 8 now becomes your n. So we want to get S8. So S8, sum of the first 8 terms. So our A is 9 in the formula. Then we do 1 minus a third. Please put brackets, power 8. Then 1 minus a third. So here again, you can start by working out a third power 8 and put the third in brackets. Because if you don't, you just be raising 1 power 8 divided by 3. That will just give you a funny answer. So put a third in brackets in the calculator. Then raise it to power 8. Put equals. Don't press the AC or the on button. Then do 1 minus A and S, minus answer. Then put equals again, times 9. The answer you get, divide by 2/3, because 1 minus a third is 2/3. Divide by 2/3, and you will get an answer. Check your answer, the one you're going to get. You should get something like 13 and 121 over 243. You can also get that one in decimals, which will be 13.498. So that will be the sum of the first 8 terms in this particular progression. So that's how you apply both formulas. When R is greater than 1, you apply the first formula. When R is less than 1, you apply the second one. So you can also be told to get anything else from that formula. You can be given the sum, then you get A. You can also be given the sum and everything else, including N, you get R. So having known the formula, you can be able to use it in any way depending on which area the question requires you to get. So practice more. For the whole of this topic, I have been repeating almost in every lesson, practice. So the essence of understanding this topic is practicing. I have taken you through the skeletons, the formulas, and maybe one or two examples. So what will make you understand this and know how to use these formulas is your effort in practicing. So practice more and you will become perfect. Thank you very much. Have a nice day.